All right, boys and girls, today's lesson is lesson 2-13. And today we are going to, I guess in a sense, start to get ready for the test coming up. It'll be coming up soon. So when the test gets here, obviously a lot of the stuff that we're going to be working on from now until the end of the unit will be almost review. Today, some more word problems with multi-steps, and then I'm going to go over a function machine with you. And then after this, pretty much is all almost review. And we'll plan on taking the test the next few days. So let's get started by turning to the first page, page 145. This is write an equation and solve the problem. Okay? Most importantly, when it tells you to do this, and it's two-step because above it says solve two-step board problems. Most important thing is to just slowly think through it. Okay, slowly figure out what they're asking. Don't rush through it and see numbers. Okay, add, subtract. If it says solve multi-step word problems, it doesn't necessarily mean it's addition, subtraction, multiplication, or division. You have to figure it out for yourself. So for number one, it says Raul spent 10 minutes doing homework for each of the 5 subjects and 15 minutes for another subject. How many minutes did Raul spend on his homework? Well, he spent 10 minutes times the 5 subjects plus the one subject that he spent 15 minutes on. You know to do multiplication first. We could do n. You know to do multiplication first is 10 times 5 is 50 plus 15 is 65. So 65 minutes. Number 2. At Sonia's cello recital, there were 8 rows of chairs with 6 chairs in each row. Well, we know right now 8 times 6. There was a person in each chair, and there were 17 more standing. How many people were in the audience together? Well, you had 8 times 6 of the seats, and every seat was taken, plus the 17 people that were standing. So, ultimately, it's 48 plus 17, which equals 65. 65 people. Okay, next one. Jana played a game with a deck of cards. She placed the cards on the floor in 3 rows of 10. If the deck has 52 cards, how many cards did Jana leave out? Well, we would do 52 minus 3 times 10. Okay? That would tell you how much she left out, because 52 is our big number. Okay, so we can't subtract 52 from something because we're talking 3 rows of 10. So 3 times 10, and we would do that first. So you'd have 30 there. So you had 52 times 30. I'm sorry, 52 minus 30 would equal 12 cards left out. Next one. Mukesh was making 7 salads. He opened a can of olives and put 6 olives on each salad. Then he ate the rest of the olives in the can. If there were 51 olives to start with, how many olives did Mukesh eat? Alright, so first of all, you have 51 total to start with. He put 42 on salads, then he ate the rest of the olives. So 51 to start, and minus the 7 times 6, then that would get your answer. So 7 times 6 is 42, so he did 51 minus 42 would equal 9 olives is how many he ate, because there were 42 on salads. Next one. Peter wallpapered a wall that was 8 feet wide by 9 feet high. He had 28 square feet of wallpaper left over. How many square feet of wallpaper did he start with? Okay, so he used 8 times 9, and he had 28 left over. So it would equal 72 minus 28, and that would equal 42 square feet left over. Not left over. How many square feet did he start with? You know, now that I look at it, I did this completely wrong. It should be plus 28. So, because he used 8 times 9, which is 72, and he had 28 square feet left over. So you would add that 72 to it, because that tells you how much he started with. So this is not the right answer. So you would get 72 plus 20 is 100 square feet. Wow, I tricked myself. For a second there, I'm like, that doesn't seem right. Because it says he had 8 feet by 9 that he had to wallpaper. So he wallpapered 72 square feet. But he had 28 square feet left over. So you add that to it, and that tells you how much he started with originally. All right, so let's turn to the next page. We're talking function machines here. Okay, or function table, sorry. Function table is a table of ordered pairs. For every input number, there is only one output number. The rule describes what to do to the input number to get the output number. It says write the rule and then complete the function table. You can't just look at the first one. Okay, some of you might say, oh, it's plus 35. Some of you might say it's times this, or well, plus 35 and multiply this. But so your options you could do are plus 35 or times 6. Okay, 7 times 6 is 42. So this one we can't tell yet, and this one we can't tell yet because it's missing. But here is another one completed for you. So would this be 36 plus 35, or would this be 6 times 6? Hopefully you can tell that it would be 6 times 6. So the rule is times 6. If that's the rule, now we do 8 times 6 is 48. And then we do 54 divided by 6, give you 9. Because if we're going backwards, you have to divide. Number 7. Okay, so our options are 81, and then we start with 81, and we end with 9. So if we start with 81 and end with 9, let's see, our options are subtract 72 or divided by 9. So let's see if there are any more that work. This one we can't do, and this one we can't do yet. But 45, can we subtract 72 to get 5? No. So our other option is divided by 9. So 45 divided by 9 equals 5, so that's correct. So our rule would be divide by 9. So that means anything in the input you would divide by 9 to get the output. We can do 72 divided by 9 to get 8. Here we can't find it yet. We can't divide by 9, so we do the opposite. We actually take the output and multiply it by 9 to give you 63. Okay, when I draw, sometimes I'll draw pictures for an input or a function table. And I'll do stuff like this. Okay, okay, so the number would be, for example, we did 81. The rule is divided by 9, and when it comes out, it equals 9. So, however you would want to do it, this is how it would look. And obviously, for our divided by 9, that last one, we had, I guess I could have kept the rule on there. We had already 7 here. So we don't divide by 9 when we're going that way. We do the opposite. So instead we would multiply, because it's a division problem, but it's but we're going backwards because we have the answer already. All right. So that's my little function table I like to draw. However you want to draw yours, that's fine with me. All right. So I'm going to do 8 and 9. I'm going to let you do 10 and 11 on your own and work on some other workbook pages. So let's quickly get to this. 4 going in to the rule and then coming out 28, and 8 going in the rule coming out 56. An option could be plus 24, and another one could be times 7. So let's see if either of them work for the next one. 8 to 56. 8 plus 24 is 32, so this one doesn't work. 8 times 7 is 56, so we know our rule is times 7. If that's the case, this is easy for us because we both have the inputs. That would be 6 times 7 is 42. 7 times 7 is 49. Next one, we start with a 32 and come out with an 8. So an option would be minus 24 or divided by 4. Okay, do any of these other ones, can we see them? Yes, we can do this one now because it has the input and output. Can we do 8 minus 24 equals 2? No. Can we do 8 divided by 4 equals 2? Yes. So that tells us our rule is divided by 4 here. Okay, so here we have the output, and we're trying to find the input now. And the rule is divided by 4. Because we have the output and we're trying to find the input, we reverse it. So it's actually times 4 when we're going that way. So our answer is 12. And then 24 divided by 4 is 6. All right, I'm going to let you work on these last two on your own. We're not going to work on them together. We'll talk about them in a small group. And then if you do have time still, the next few pages, there are some, or the pages before this, in case you didn't finish them. But the next few pages, there's a lot of, actually, if you finish this and you have time, go back through pages before this and knock out anything you haven't finished.